Hi, I'm Steve Reagan with CSO Online. I'm in the Speakers Lounge at Circle CityCon again. With me is Martin Boss. He is with Trusted Sec, and you just did a really interesting talk on passwords. So, as everybody knows, passwords are by far the weakest form of protection we have with our online accounts and our networks and everything like that. But it is all we have, and it's what we have, so we kind of have to make the best of it. But you've discovered that there's been a long-running series of problems. So really quickly, give me a brief overview of the talk you just gave.
Sure. So passwords have been in the news again recently. There's been several dumps that have come out, LinkedIn, MySpace, a couple other ones that have hit the internet. And so it's another hot topic of conversation. And so basically, I brought back the talk. Years ago, I did a talk about how bad password policies were and how organizations needed to step up their game based on the advances that crackers were making with GPU-based password cracking. And so, unfortunately, 5-6 years later, after I given that talk, the penetration tests that I go on and the web applications that I look at or assess or even use on a daily basis are still using the same, short passwords. And by short, I mean 8 to 10 characters. But, when you're cracking 9 billion passwords a second, 10 characters is short, comparatively speaking. And so I haven't seen a lot of advances in getting better password management in enterprise environments and in applications.
So some of the problems you highlighted are predictability in the way passwords are created, and one of the biggest things that you hammer on is password policy and policy enforcement. So what is it about password policies that makes this such a problem?
So traditionally, we've done things like complexity, right, where we've required certain, an uppercase character, a special character, and so that's a complexity requirement. However, we've still left up to the user to be able to make their own pattern for the password. And so the patterns are really predictive. The example that I always like to use is the uppercase character. If I require you to have an uppercase character in your password, 9 times out of 10, it's going to be the first character in the password, because that's what we're conditioned to do, is capitalize the first letter. So what I would like to see is, instead of complexity requirements, I'd like to see checks for what we call topology. So where we have patterns that we can define. So in the talk, I talk about Hashcat, where we use variables to define the patterns. So if we could have checks for password policies against well-known patterns and deny passwords based on patterns, rather than, we already do it to an extent. We say you can't have your username in your password, or you can't have your email in your password. But what if we were able to say, the first letter of your password can't be an uppercase character, right? So that would take away from the pattern that we already know is very popular with passwords.
So when Trusted Sec is doing an engagement, these types of predictable policies and the predictable password sets that people use, that's mainly your biggest help when you're auditing a network, isn't it?
Yeah, absolutely. So one of the first things I do in any Windows Active Directory domain is query the domain controller and find out the password policy for the organization. It tells you right there. And obviously we can't prevent that. However, if there was some back-end stuff, there are some third-party tools to manage passwords, and there are third-party tools that allow you to put different rules and regulations in there for not creating passwords. Like the example I used was, no uppercase first character. So if I administered a domain, the first thing I would do is find some type of tool that would allow me to not let people uppercase the first character. It would, not put a special character at the end, and not be able to use a date. I would have a database of dates. You could use a sequence of numbers, but it could never be a date. That kind of thing. And so once I query Active Directory, I get the password policy, and I know, if the password policy is 8 characters or 9 characters or 10 characters, I know that there's a certain percentage of people that are going to do the bare minimum for the password policy. And it's not really their fault, I always pick click on HR as an example, like they didn't get hired to be secure. I mean, they're not concerned with securing the organization, and it shouldn't be. That's IT security's job. So while I do believe in educating the users and talking about, how to make a good password and all that kind of stuff, you're never going to reach all of the users. There's going to be some people that don't care, some people that were out sick, some people that, were playing on their phones or whatever. So a little bit of user education can be effective, but overall, I'm more of a proponent of technical controls in place so that we just can't make passwords based on bad password patterns.
When it comes to the patterns, this was something else you mentioned in the talk. How are password patterns helping attackers target and go after an organization? It's a time thing, right?
Yeah, I mean, it's just much, I had a graph in my talk where it showed, we had a 7-character password, and it showed if you had to brute force all 96 characters in each position, it would take, I think it was, 73 seconds or something like that. But then in the graph under it, it had a picture where it narrowed down, what if we knew the pattern of the password? What if we knew it was an uppercase, 5 lowers, 2 digits, and a special? And then it showed that based on that pattern, I could crack the exact same password in 6.2 seconds or something like that, right? So, I mean, obviously we're looking at that on a much larger scale for a penetration test because we're cracking a lot more passwords. But that just shows you if I have any information whatsoever about the pattern that the organization is using, and chances are if one person does it, the other person does it, right? Coworkers talk, they have the same seminars, they have the same user education, they have the same user manual that they have to go through so if I find one pattern in an organization, the chances are good that I can replicate that pattern over and over and over again and compromise more passwords. And the same is true on a web application as well. I know you've clicked on a web application and tried to enter a password, and it says, that doesn't adhere to our policy, you got to do this, that, and the other. I mean, they give up the information right away, right? Instead of having a really generic error message where, it just doesn't, match our policy, they give you the specifics on the policy. So, once you recover a couple of passwords and you see that policy, you just keep replicating that pattern over and over again.
And that's the masking inside of Hashcat is really good for enumerating those patterns when you spot them out.
Absolutely, that's really the real power of Hashcat is that you're able to predefine every character set with a separate mask, and if the default masks don't match, you can create your own, right? So, for example, if you wanted to have a mask in hex, was one of my examples up there. So upper and lower digit doesn't cover hex. So since hex you only need up to F in the alphabet, you can create a custom character set that has 0 through 9 and then A through F, and then it will create all the hex combinations. So for me, that's the real power of Hashcat.
That is pretty impressive. So, final thoughts. What type of advice do you have for administrators who are maybe looking to augment their password policies or how they deal with passwords in-house, but yet not have to worry about someone saying that's not best practices?
So the two biggest things I look at is finding, like I talked about before, finding a way to prevent common patterns from being used. And so I showed a couple of tools in my talk out of our password analysis and cracking kit that show you can run them on a word list and they show the top 10 or 20 patterns in the list. So even just denying those top 20 patterns somehow from being used in your environment is exponentially better. Obviously you can add a little bit of length onto the password, but at some point, I've seen organizations go up to 10, 12, even 16, but at some point the usability of people actually doing their job starts to come down. So that's why I really like to focus on patterns and keeping the common patterns out of the equation because it takes a little bit longer. And then third, and this was talked about in some other talks and a little bit outside of, but enterprise password managers can be helpful. I know that there are not a lot of them out there. There's a lot of personal ones that people use, but there's not a lot of enterprise ones. Unique passwords, not having the same passwords across your environment, that type of thing. Those are all really helpful for administrators to drill down at organizations. And then the very last thing, something that I advocate really heavily is, quarterly or monthly or whatever password audits in your organization. And there's not a lot of companies doing this. I don't know how many other companies offer it as a service. Obviously, I'm going to say we do at Trusted Sec. However, it's really important to, go through and see if all your passwords meet your policy. I don't know, a lot of times I've done penetration tests where we've, dumped an Active Directory database and we found a bunch of 4 or 5 character passwords in there. Then they come back and they say, well, how did those get in there? They don't meet our policy. But what has happened is some domain administrator has bypassed the policy so that he could run a service, with a bad password. And so that happens all of the time. So password audits can catch that kind of behavior.
Excellent. Thanks a lot for coming out.
No problem. Thanks very much for having me.